Greetings, Rohill. This is Mr. Caslin. I just wanted to go over a problem that we were looking at right at the end of our session yesterday. This is a mixture problem. This one's a little bit harder than the others that we were looking at, I think, because they don't tell you any amounts that you're dealing with here. So we're still going to use the same framework we used yesterday. All right, so in a mixture problem, I always talk about you've got item 1 and you're mixing it with item 2 and you have a new mixture with new percentages. All right, so yesterday we talked about you have the amount of item 1 and its percentage of a certain material. One of the problems we worked with, I think had sand in it, one had acid in it. This one's talking about the percentage of peanuts. All right, so let's get started on this one. Now, this one, we're also dealing with a ratio. We didn't deal with any ratios yesterday. This has 3 peanuts to every 2 almonds. All right, so when you're dealing with a ratio, let's turn that into the fact that we have 3 peanuts out of the total number of items. So let's make this the fact that you've got 3 out of 5. 3 out of the 5 things in there are peanuts. The other 2 are almonds. All right, and we want to end up with a mixture that has 5 peanuts out of the total, which would be 7. Okay, now we're mixing pure peanuts. This is kind of like the acid problem we worked with yesterday. We're mixing pure peanuts, so 1 out of every 1 item that we're adding is a peanut, which is just 1. Okay, so those are our percentages. Now, what makes this difficult is they don't tell us any amounts that we're dealing with in this problem. All right, so the way I would set this up, and there's lots of different ways to do this problem, but I'm trying to keep it in the same structure we worked the other problems yesterday. So when they don't tell you any amounts, what I'm going to do is consider that we're starting with 1 unit of the first item, which was the one that had the ratio of 3 peanuts to 2 almonds. Okay, and this is what we're trying to find out. We're trying to find out what, it's a odd way of asking how much of this do we need to add to this? So our answer is going to be like 50% of this compared to the original amount, or 60%, or we'll see. Okay, so later on we're going to change this to x and say our answer is going to look something like 0.5x. Meaning for every unit of this first item, we need half the amount of the second item. So if our answer is 2, then it would mean 2x. We need 2 times of the pure peanuts added to item 1. So I thought the problem is worded very strangely, and the fact that it used x for that variable was odd. But so we're not going to use x as our variable here. We're just going to say we want this to figure out what this amount is. So we'll just call this variable a. Okay, so we have 1 unit of item 1 that has this ratio. We have this amount. It's got pure peanuts in it, and this one then will be a combination. We'll call this 1 plus a, because we're adding the 2 amounts together. And it has now this composition of 5 peanuts for every 2 almonds. Okay, so you're going to solve this. Now the rest of this is just a fraction math problem. You've got 3/5 plus a. Pardon me, I don't write very well with this mouse. I need to find a good writing device for a computer. All right, make sure you distribute here. You've got 5/7 plus 5/7 a. Make sure you just distribute to both items. We're going to solve for a just like you would any other equation. We would subtract 5/7 a from both sides. We would subtract 3/5 from both sides. I'll let you work on the fraction math on this to get that right. What you're going to do when you solve this, you're going to get a is equal to 2/5, I believe, which is also equal to 0.4. Okay, 0.4. So let's interpret what this answer means. This answer means that instead of 1 unit, what if we had X units? Okay, so if we had X units of item 1, we would need 0.4x of the amount of item 2. Okay, so it's 40% of whatever the amount of item 1 is. So that's what it means, is express your answer in terms of X. It means your answer is going to have a variable in it because we don't know what the exact amounts are. Okay, so again, you have a mixture starting with, you're adding a different mixture and you're getting a new mixture, and you're always talking about amounts and percentages, and some of these can be a little more difficult when they don't give you the exact amounts that you're dealing with. Okay, hope this helps. Again, there's different ways to approach this, so if you need to see another solution, that's just fine. Hopefully they're getting the same answer that we got. All right, we'll talk to you next week.